All right, so real quickly, I just wanted to go over identifying the different variables, those being independent variable, dependent variable, constants in your experiments, and then controls. Okay, each one of these has a very important purpose, and I wanted to kind of go over these with you so you have a good understanding of this. So, independent variable, IV, that is the quantity that is changed by the experimenter. Again, me personally, I recall or remember that one because independent variable, I change it. So, I, as the experimenter, am changing the independent variable. Now, the second variable that we're going to look at is the dependent variable. This depends on the independent. Oftentimes, again, I'm a one-word definition person. Independent variable is what I change. So the dependent then is the result or the effect. So independent could be the cause, the dependent could be the effect. Now again, textbook definition says that this is a quantity that changes as a result of the change in the independent variable. Okay. Now, if I give you a graphing example, and I'll show you guys a couple in a little bit, the x-axis is the independent variable, the y-axis is the dependent. Okay. Now, a couple other parts that I wanted to take a look at, one being the constants and a problem. Now, any experiment that we do, for it to have validity, what needs to happen is we need to keep other parts of the experiment constant. Okay, because if I want to make a conclusion or draw a conclusion, make a connection from my independent to my dependent, then everything else needs to stay the same. So for that purpose, they're called constants. They do not change. Okay, again, we'll give you an example in just a sec so you guys can kind of have a better understanding of what I mean. This is abstract. And then lastly, your control group. Now, here's your textbook definition of your control group, the standard for comparison, the trial that illustrates normal situations. Now, I'm going to go ahead and make that go away again because the definition that I'm going to verbally give to you, I think, is better. Okay? Your control, to find your control in an experiment, is two things. First thing, it needs to be one of your trials. Okay? So in any experiment, you're going to have at least two trials, if not more. Your control group or your control trial is going to be one of your trials, like I said. The second thing that your control has to do is your control has to represent normal circumstances. We usually use our control group to make comparisons, to make a judgment on whether or not the conditions we're putting into our experiment make a change. So for that purpose, our control group then is the one that we use to represent normal circumstances. Okay, that is basically it. Now here's an example. Okay, a farmer's raising cattle for the county fair, wants to raise the largest cows he possibly can. There are 4 groups of cattle, all same sex, individual starting size, breed. They live in the same conditions. There are 4 groups. Group 1 gets vitamins, Group 2 gets protein, Group 3 gets Taco Bell food, and Group 4 receives no dietary supplement. So if I'm to go ahead and identify the parts of the experiment, independent variable again would be what I change. So the independent variable here is what condition the cows receive. Food, supplement. Those are your independent variables. Okay. Dependent variable is the effect of changing that. So the dependent variable in this case would be the growth or the size of the cattle from those conditions. Okay, now constants, again, they're all listed out here for us. They have to be the same sex, the same breed, the same initial starting size. They live in the same conditions. All of these things have to be the same if I'm going to draw the conclusion that my vitamins or protein, Taco Bell food, whatever the dietary condition is, if I'm going to say that that actually is impacting their size. Okay? Control group, again, 2 things. It's one of your 4 trials, so it's going to be group 1, 2, 3, or 4, and it's going to represent our situation normal, which would be group 4. They don't receive any dietary supplements. Normally cows don't get Taco Bell. Okay? So I also want to show you guys a quick example on paper because I think this might be helpful for you as well. As soon as my document camera decides to work, there it is. Okay, here's another one. Put this in the screen for you. So here's a sample problem now. Hypothesis: the greater amount of HGH, human growth hormone, you give a buffalo, the more weight it will gain. So here's the experiment. There are 4 young buffalo. They all start out 100 pounds. They're all 6 months old. Okay. One buffalo gets no growth hormone. The second gets 10 mils. The third gets 20 mils, and the fourth gets 25. Now each buffalo is given the same amount of food, same water, same amount of exercise. They are given everything absolutely the same. Okay, they've weighed the buffalo 45 days after the shot. Now, here's the data after those 45 days. Okay, so again, here are your 4 groups. Okay, here are your results or increases in weight. I want to know independent variable, dependent variable, constants, control. Okay, so the first one, independent variable, what I change. Again, remember, we're changing the human growth hormone. Okay, so if they're getting HGH or not. Okay, that would be the treatment. Now the dependent variable, we're changing this. As a result, we think it's going to change the weight gain. Okay. And like we just looked at, if I were to graph this, my independent would be on the X, so it would be HGH, and that's in mils. Here's 0, 10, 20, 25. Okay. My Y value would be weight gain. Okay, and that's in pounds. And again, be up to 100 pounds here. Here's 0. My graph would look something like that. Okay? So again, weight gain is going to be my dependent. That's on the Y. HGH goes on the X because that's my independent variable and my dependent variable. Now control, again, remember, it's one of 4 trials, so it's going to be one of these 4. Okay, and it represents normal situations. So in this case, normally cows, or actually buffalo, excuse me, do not get HGH injections. That's actually, I think, illegal. But anyways, you know, PEDs for cattle might not be the best thing anyways. So control group, normally we get no shot. So that's going to be no shot. Okay, now constants, again, like we said above, there's a whole bunch of different constants. Okay, each buffalo is given same amount of food. That's constant. Okay, the same amount of water, same amount of exercise. Okay, they live in the same conditions. So that would be 3 constants. They're also all weighed 45 days after. Okay, so those would be some of your constants that we could talk about. Now lastly, does the data support the hypothesis? Well, let's take a look again. Hypothesis is the greater amount of HGH you give buffalo, the more weight it will gain. Well, here's our graph. Here's our data, and clearly we have an upward trend. So yes, the data supports. And then let's cite some data as well. Okay, no shot is 40 pounds. Okay, 25 milliliter shot. Okay, that was 100 pound gain, which is much greater. It's actually 60 plus pounds greater. Okay, so hopefully that clarifies some things for you guys. Again, constant, control, independent, dependent variable.